Buenas tardes. Es mi primera vez aquí en Málaga. Soy brasileño, no hablo español. Por eso mi charla será en inglés. Okay. Okay, I think then it sounded good, at least I hope. Yeah? But it's interesting because we Brazilians, we can understand Spanish, but we cannot talk Spanish. We can just say Portuguese with a Spanish accent. So I don't think you would understand me if I talked in Portuñol. So just try English. Okay. So I'm the Director of Developer Experience at Red Hat from the Red Hat Developers Program. I'm also a Java champion and currently also a Microsoft MVP. So that might sound a bit weird, having these two titles. So we're living in a different world right now. And I always like to start my talk saying this sentence from Forbes: now every company is a software company. Because I believe that absolutely no innovation is going to happen in the next 100 years if it's not going to happen through software. So I think I can say that we at this room, we have some part of the most important people in the world, because we developers, we are going to create the change that is going to change the world, that's going to change the people's lives, certainly for the better. And some examples that we have of this new economic evolution is that the largest car transportation company in the world doesn't own any cars, which is Uber. The largest accommodation company in the world, which is doesn't own any real estate, which is Airbnb. The largest online retailer in the world doesn't own any stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. Okay. It's questionable content, but it's still content. And we know that all of these companies have in common is they all exist because of software. So software is changing the economics of this world. And when I studied a bit of economics, before studying, I always thought that economics meant something around money. But then studying economics, I realized that economics is about social systems. It's the way that social animals, in our case humans, interact and try to produce some output from the system. So software is a social system, is a social ecosystem, and we're part of that. And as software developers, we know that the result of our job, it can be wonderful, we can change the world, we can change the people's lives for the better. But we also know that the output of our jobs can also be terrible. We can make other people miserable. Yeah, and we know that because we feel miserable when we use crappy software. So the challenge that I want to leave to you, to all of us, is on which side do we want to be? From the one that changes the world for the better, or the one that makes other people's life miserable? Okay, I know you choose wisely, okay? And since software is a social system, software is made by people, for people. Sometimes we forget that, and always when we forget about how software should be developed, the output is non-optional. We don't achieve the results that we would want to achieve. So when we're talking about microservices, maybe we should be talking about how teams, how groups of people join together to develop software. That's one of the points of my discussion. And we're also talking about legacy. Since I'm going to talk about from monoliths to microservices, I have to talk about legacy. And I'd like to say that legacy usually brings some bad feelings when we talk about software. Nobody wants to deal with legacy software. So legacy means something bad. But if you look up in the dictionary, legacy doesn't necessarily mean a bad thing, because legacy, the definition of legacy, is something that you leave behind for others. So in my life, I think that my life's purpose is to leave something behind for my kids, for the people I love, for the people I don't know. I want to leave the world a better place compared to when I was born. So I want to leave a legacy. So in software, why don't we want to leave a legacy? At least we don't want to leave a legacy that we have to maintain. Yeah? We leave for others to maintain that legacy. Okay? So I'll try to give a different definition of legacy, which means that any code delivered into production is legacy. That's the definition of legacy. And if anything is running into production, it means that it's delivering value. So, you know, I particularly used to criticize a lot my code and even more others people's code. I saw that, oh, that's crappy code, and in the others it's crappy code too, even if it was the code that I've written 2 weeks ago. So I used to be very critical in these aspects. Now I try to not criticize people because I'm pretty sure, at least that's what I want to believe, that when that people wrote that crappy code, they did the best that they could do at the moment with the knowledge they had about the business case, with the knowledge they had about the technology. And I'm pretty sure that if they did that again today, they would do something much better. And I've learned it last year from a professor from Uberlândia, Brazil. He told me what is the definition of competence, because I always thought that competence means proficiency. If I'm a competent person, if I'm proficient in what I do, but then I learned that competence comes from Latin, which is competere, and competere means to compete against yourself, not against others. So if I compete against myself, and by the end of the day I win, if I'm a better person when I sleep compared to when I woke up, I'm a competent person. So competence has nothing to do about proficiency, but competence has everything to do about self-improvement. So that's why I believe software should be developed. Software development is a journey, and we always need to do better. It would be a sad day in my life, the day that I saw a code that I wrote yesterday, and I would have to say that, oh, I'm never going to be able to do such a great thing again. Then probably should be my retirement day. I would be looking for something else to do, because I wouldn't be anymore a competent person. And since we're talking about software, and software is made by people, I'd like to talk about the concept of feedback loop. We humans use the concept of feedback loop in everything that we do in our lives. That's the way we learned how to ride a bicycle. That's the way how we learned to talk when we were kids. We didn't know how to speak the words. We just created some sounds. We needed the auditive feedback. We need our parents' feedback, our grandparents' feedback to know if we were pronouncing the words correctly. That's how we learned how to speak. And with software, is absolutely the same thing. The longer the feedback loop that we have in the software process, the worse is the output. So I'm a Java programmer, and sometimes I invade some people that use dynamic typed languages, so they can just type and save your file and automatically see the result. So you have a short feedback loop, so it improves the output of because why is the feedback loop so important in the software process? Because it allows you to keep the context in your mind. And the definition I give to context to you is, context is the amount of things that you can hold in your mind at a given moment. So the worse the feedback loop, the lesser context you can keep in your mind, so your output is worse, because, you know, sometimes we as Java developers, at least that's my case, I'm trying to implement a new functionality. I just save the files. I start a Maven build. It takes 10 minutes. Then I have to deploy that file. I try to deploy that. Takes another 10 minutes. Then I go take a coffee. I go to the restroom. I talk to my colleagues. Then when I come back, I look at the screen. What I was doing before trying to build and deploy the software. I lost the context. Now I'm going to take another 30 minutes to recover the context in my mind to try to continue my work. So if I lose context, that's a bad thing for software, and that's why we're trying to always improve the feedback loop. We always have the feedback loop from business people, because sometimes they want a new functionality. They say, oh, now the business scenario is this. I think that if we change this or change that, it's going to improve my sales. But sometimes we take 6 months to deliver a functionality. So when we deliver that, the business scenario already changed. They don't even remember why they asked us to deliver that new functionality. So the longer the feedback loop is, the worst is the output. The worse is the output. So we have to try to improve the feedback loop. And when we're trying about improving the feedback loop, the question that I ask to you is, what is preventing you from delivering faster? if our objective is to deliver software faster into production, what is preventing you from doing that? And I've chosen some common problems. I'm pretty sure that the list is very extensive, but it shows some simple samples of that. If you have too many bugs in your software, you don't have the confidence to put that in production. That's why we create QA teams, and they find a lot of the bugs. In fact, QA teams, they never solve bugs. They just say that, okay, we have 10 non-critical bugs. I guess it's okay to go to production, okay? So we have too many bugs. Maybe that's because we don't have enough testing, because sometimes testing gives us the confidence that we need to put that software in production. And we have a lot of different tests for that. So testing allows us to shorten our feedback loop. You know, you just have to run your test to know if your software is running correctly. So it decreases your feedback loop. Sometimes we have integration problems, and I know how many of you remember that time. We used when the only day that we did a full build of our software was the deploy day. So everybody used to do CVS and commit on the repository. Nobody checked out the code, a clean code, and just to try to take a build. And in many companies in the past, the only day that they did a full build of the system was the deploy day, just to figure out that it wasn't even building. The code didn't even compile. Okay, and in some cases, we even have a large bank in Brazil, which I can say the name. But the guys that deployed the system was the ops guy, not the developers. So the code didn't compile. They just kept opening each one of the files that didn't compile, and they were just commenting out the codes, okay, until the code did successfully compile, and then they deploy into production. Yeah. Then sometimes some weird things happened. Okay. Yeah. You can guess. Yeah. So continuous integration tried to solve the integration problems, which is the worst class of problems that we have in software development, integration problems. How our code work with other people's code. So continuous integration tried to solve this problem by doing it more often, every night or every hour or in every commit that we did. So we tried to resolve the problems by by having a quick feedback. If I commit something, oh, I know I broke something, because the continuous integration server just notified me. And sometimes I can deliver software fast into production because I have a manual deployment process. I have to do a lot of manual tests to deliver software to production. So we try to solve that problem by implementing continuous delivery or continuous deployment, by removing barriers between devs and ops people, and creating an automated software pipeline. And now, we're trying to solve another class of problems, which is, again, integration problems. That's what microservices are for. So many people think that microservices are supposed to scale software. Oh, I'm going to need to scale software because I'm going to have many users. Usually, it's not the case because we have many different techniques to scale software. But with microservices, we're trying to scale people. Okay, we have a large code base. When we have a large code base, we just keep adding people. And the more people you add to a code base, the harder it is for you to know if your code is going to break other people's code. So now you have integration problems again. And the larger code base it is, you have to keep your mind a larger context. So it's really hard for you as a developer to know if anything that you're doing is not breaking what other people are doing. Okay? So that's the problem of big context and big code bases. Sometimes, and usually, someone messes something and it breaks your code and you break the other people's code. So with microservices, we're trying to solve the problem in a different way, but it's the integration problem again. So remember, microservices, we're trying to scale people, not software. And how we're trying to achieve that? We're solving integration issues by reducing the context to a cohesive microservices. We're trying to split some kind of functionality from a big system, from a big code base, into a cohesive code base, which, like you see, if we look back 20 years from now or 30 years from now, in software development, we're always trying to produce code that is highly cohesive and has low coupling. Yeah? We try to do that with modules. Okay? We try to do that, again, with packages, and we try to do that with classes, and now we're trying to do it again with microservices. So my conclusion, personal conclusion, is that we're always doing it wrong, and we're creating a new technology, a new point of view to try to solve that problem. We're very bad in creating cohesive Unix with low coupling. Microservices, we're trying to do it again, because you know, cohesive software and low coupling has nothing to do about technology, but it has everything to do about how you model your business domain. So the main issue is the business domain. And like every microservices talk, I always have to talk about the Conways Law, which I'll give you the short version, which means the software architecture of the system must mirror the communication between the people that develop the software. What does it mean? We have a large group of people developing the software, and sometimes when we have a small team, everybody knows what everybody's doing. Everybody knows if he does something, I have to do this. But when the team grows, it's something almost natural. If I had to say that the team grow, naturally we get to split the team. So we have this team from the left and this team from the right. And when we create the separation, naturally, it's us versus them. So we are going to create this functionality, but I need information from them. So I'm going to give you this information, and you're going to give me back this information. And this team again, I need to deliver this functionality, so I'm going to give you this information, and you're going to give me back this information. Doesn't it look like an API? Naturally, it looks like an API, because that's the communication between the teams. People, naturally, they create protocols between other people, between teams, and create some sort of information exchange between the teams. With microservices, we're just trying to get these implicit APIs that we have between people, and we're trying to make it explicit with code. We're creating APIs in code just to mirror this communication infrastructure. So the best recommended approach so far for creating a microservice architecture is you create first a monolith. It doesn't have to be a big monolith, but you create just one single deployment unit. And when you have enough knowledge of the business domain, you may try to split and try to mirror the social structure of the people developing software. I've been able to spend a whole afternoon with Rand Shoup, which is the former director of technology from Google and eBay. And something very interesting that I've learned from him was that when he created these microservices architecture in these companies, they didn't plan for that. They just had a monolith code base. The code base kept growing, adding more people. Then the team automatically decided to split. Then this team started to grow again. They split again. Then many years later, when they look back, they're talking about microservices. When I look at our architecture, we are doing microservices, but that was not something planned. It just arises from the social structure of the teams. So instead of planning for microservices, maybe you should just scale your people and use the natural communication protocols that people create to create your microservices architecture. How big can be my team? You know, Jeff Bezos from Amazon created this rule, which is a 2-pizza rule, which any team inside Amazon must be fed by 2 pizza. I don't know the size of the pizza. It's American pizza, okay? I don't know the size of pizza, and I don't know the size of the people developing software, but maybe a rule of thumb should be any team inside Amazon must be composed of at most 12 people, okay? I don't know if 2 pizzas is enough for 12 people. In this case, should be. Okay. Yeah. So 2 pizza rule. But why 12 people? Because 12 people is kind of a limit where you can communicate efficiently. With 12 people, everybody knows what everybody's doing in the team. More than that, you just have to start reorganizing yourself. Maybe you need the manager. Then things start to break. Another important question about microservices is, how do I run my microservices? And you see microservices evolution when we're talking about microservices. With Monolith, you just had one single artifact to put into production. If you had a deployment issue with one artifact, what makes you think that having multiple artifacts to deploy into production, you will have fewer problems? So you must have solved first the DevOps problem. You must you must have automated pipelines for everything. Then you can start thinking about microservices, because now with microservices, you have, I like to say that with microservices, we have a toll, a very high toll. Because with microservices, now we're talking about distributed systems, and we have a whole new class of problems to solve. So maybe if you have a small team, it's not worth to create a microservices architecture, because the toll is too high for just the amount of people that you have to work on your project. So that's one of the questions that we have to think about microservices. But if you decide that microservices is okay for you, I have a large team, I have a very large code base, maybe it's better for me to scale my architecture into microservices. Where do I run it? And the answer naturally today is a PaaS. And when I talk about PaaS, I'm talking about the 3rd generation PaaS, not the 1st generation PaaS that we used to have, like Heroku or Google App Engine, which were PaaS that you had to change your application to run on this PaaS. So everybody has bad feelings when we talk about this 4th generation PaaS. Now with PaaS, I'm talking about much like container as a service PaaS, okay? We're trying to use containers as our deployment units, and all of this 3rd generation PaaS, they naturally use containers. Another question is, I want to run microservices, I know it must be run on top of a PaaS. Do I buy or build it? Because microservice pioneers like Google and eBay and other companies, Netflix, they had to build their own PaaS. They had to code that, and you know there's a lot of money and time investment on that. But now you have in the market many different options for you to buy this option from the open source world. And some good examples of ready-to-go PaaS that we have in the open source world is, I can name a few, the Docker Swarm, which is made by the same company that produces Docker, but so far it's like a beta version, not production ready at least, as far as I know. You also have Apache Mesos, which is sponsored for company and used by companies like Pivotal, IBM, and other ones. And we also have Kubernetes, which is the one that I'm going to mention here. Kubernetes is a project sponsored by Google and developed jointly by Google and Red Hat. At least we from Red Hat, we believe that Kubernetes is currently the most mature option for running your containers at scale. That's our opinion. You can have your own reasoning about that. And Kubernetes is such a low-level container orchestration platform. You don't have a full-featured PaaS on top of Kubernetes. That's why, since it's an open-source project, you have many different options for running PaaS on top of Kubernetes. So we have different options. Some options that I can tell you is DEIS. DEIS is a PaaS which runs on top of Kubernetes. And we also have Openshift, which is the open source project from Red Hat that runs on top of Kubernetes for you to run your microservices. So you have many different options. The demo I'm going to show you is going to run on top of Kubernetes and Openshift. Okay, and now from monoliths to microservices, how do I begin my journey? Because that's a journey. Most of us are enterprise developers. I know we admire Amazon and Netflix and Google and eBay and their microservice architecture, but they have very specific use cases. They have a pool of talented engineers. They have the resources, and sometimes not everybody can be a startup. Not everybody can be a billion-dollar startup. But most of us, we have an enterprise system to maintain that is delivering value. But we also, if we decide to, we can have some of the benefits of using microservices into our enterprise company. And how can we do that? So far, the most recommended approach that we have for enterprise companies is the concept of the Strangler application. I don't know how, I don't think you can recognize the picture, but there is a kind of tree. It's called the Strangler fig. I don't know if you have here in Spain, but I know that we have in Brazil, and I learned that we have in India too. So usually, there's a special kind of fig. The birds eat the fruits and they shit on top of the other trees. So when the seed grows, the roots start to grow, and when the root reaches the ground, it starts to get stronger and bigger, and it grows surrounding the host tree. And it gets very big and very strong, and eventually the Strangler feed, it gets so big and so strong that it strangles the host tree, and the host tree just dies. So that's the analogy that we want to do with a Strangler application. How we build microservices. We just build microservices around our monolith. We just create new functionality around. We just take some functionality from the monolith into microservices. Then, at some point in the moment, in the time, we're just going to realize that, oh, my microservice architecture is bigger than the monolith. Then we can just kill the monolith if you want, if the cost of maintaining the monolith is bigger than just rewriting it, the very small piece that is left from the monolith. Okay, and okay, I want to create a Strangler application, a microservice application that will strangle the monolith. But which piece do I take off from the monolith into a separate microservice? So we know Eric Evans taught us the concept of domain-driven design in 2004. And I think it's very important for us that even in 2016, we're not using it correctly yet, but I'm pretty sure we will all be using domain-driven design correctly, because that's a very useful technique for you to know how to split your domain model in what we say like aggregates and entities. I'll give you a very brief explanation, but it means that with domain-driven design, we get to know some bounded contexts which are sets of classes that we know that usually change together. So if they change together, we can try to insulate these parts from the rest of the system, so that when a change occurs inside this bounded context, you don't have to propagate the change to other parts of the system. So basically, you try to identify some highly cohesive classes, set of classes, with low coupling between other systems to create a separate microservice. And when you just decide to split your monolith, you just decide to extract your bounded context, you can start to create some interesting architectures around monoliths and microservices. So maybe the very first alternative that you have, very first architecture that we're going to create is when you have your software and you have your browser, your desktop browser, you have your mobile application, or you have your desktop application, and each piece of your application is going to access a different endpoint. And each one of these endpoints can be implemented in a different language or technology. We could have used the Wildfly Swarm from one microservice. We could have used Spring Boot for one microservice, or Node.js for the others. So it's technology agnostic, and that's an interesting consideration. Some companies, like Amazon, they let the teams decide what you want to use for your microservice. And some other companies, like Netflix, they just decide to standardize the set of libraries and tools that the team can use to create your microservice. Why? Because distributed systems are hard, and you have a lot of concepts and things that you need to implement in your microservice. So they decided that they don't want the teams to be re-implementing the same concepts again and again in different languages and platform. So they just standardize it on top of the JVM, and they have a set of libraries and tools, which is the Netflix OSS that I'm going to show you later. And they use the same set of libraries in each microservice that they develop. The second architecture that you may have on microservices is the API gateway. So now you have this scenario, and maybe you want to create an API gateway in front of your internal microservices, so that your mobile application, desktop application, or browser can just access a single endpoint in the backend. Some motivations for that is that, well, since now you have a distributed systems, you have to control authorization, authentication, security, logging, routing, tracing, and you don't want to implement everything in which one of the microservices. So the motivation for using an API gateway maybe is the same motivations that we used to have when we implemented the design pattern facade. We want a centralized point of something to create some common ground for the microservices. Then the API gateway is the best alternative for that. And you know, software architecture is all about trade-offs. You always earn something and use something. The API gateway, again, becomes a single point of failure, which you don't want in the distributed system, but you can have it all. So you have to decide. But the API gateway allows you to create some very interesting things. First of that, I like this sentence a lot, which is reliability must come from software, which is from Def Dean Google. And which doesn't mean, which you can rely on hardware. Hardware fails. And you can rely on infrastructure running your applications too, because the infrastructure fails. You have network issues, you have latency issues, you have unavailability issues, you have a lot of different things that can happen. And for your system to be scalable and reliable, you must design for failure. You must code all of these things that can prevent your software from failing inside your code. Okay, so design for failure is a thing that you must have in mind when you're coding. And we have a lot of different patterns for implementing in code for design for failure. If I would like to give you an advice and say to you just choose one, then you should be implementing the circuit breaker or book held pattern, which is which basically means that you need a distributed try-catch. With microservices, you have a lot of moving parts to produce one result. With the monolith, it was easy. It was on or it was off, so you just had one piece to worry about. But with microservices, you might have 30 microservices, and you can't allow your system to be unavailable just because one of the microservices went down. So you must be prepared for that. And how do you code that? Use the circuit breaker. Circuit breaker pattern is much more fun when you code that, but just to explain you a short version, it's a distributed try-catch. Basically, it means I have an endpoint, I try to access another endpoint, and if it fails, I just reply with a default fallback for that, which means I try to query some information. If the service isn't available, or if the service takes too long to reply, then I'm going to open the circuit, and I'm going to give them a default answer, okay? Oh, but my system, my business case doesn't allow me to create a default answer. Oh. You have many different ways of computing your default answer. I'm going to show you some examples later, talk about some examples later. But the fact is, you can never allow an exception in your code to break the response to your system, to your end user, okay? Another interesting pattern that we have inside the API gateway is smart routing. You know, now we talk a lot about DevOps. We want to do A/B testing. We want to do blue-green deployments. We want to do canary releases. And for that, we need some smart router for that. Because, you know, maybe my application, we're having issues with the iOS users, but the Android users are okay. So I can create a new deployment, a new version of my application. And in the smart router, I decide to implement the logic that if the request comes from an iOS device, I'm going to route this deployment, or else comes to the default deployment to check if everything is okay. That's a kind of A/B deployment, A/B testing, A/B deployment. Then we can also use canary release, because I create a new deployment from a new version. Then I start with 5% of the requests come here. Then it's going okay. I can increase now 10%, 15%, 20%, but it must be dynamic. I don't need to redeploy the API gateway to do that. So we can use some smart routing. Zoo from the Netflix OSS stack is an interesting implementation of an API gateway using smart routing. And before I keep going with slides, I want to show you some code. So I know I have a very short time, so I'll give you the small version. How many time do I have? 10 minutes. Okay, that's going to be a very short demo. So I just created here. I'm going to access my Openshift console. And then, luckily, I already have deployed my services. So what I want to show you is this application. Okay, you're not seeing that. Now I'm going to show you. Okay. Now you see the Openshift console. I already have deployed some versions of my application, and I'm going to show you this. Okay, I'm just good. Okay, you can see that? Okay, that's an AngularJS application. It's accessing some endpoints. So what I want to show you is the offer from the bookstore is a different endpoint. It's a separate microservice. So when I try to access here, and I try to create an offer, I'm going to say discount, 5%. And when I save that, you can see I have a discount of 5%, so it's saving on a separate endpoint. But what happens when I have my infrastructure and suddenly everything is deployed on top of Kubernetes and Openshift? Then for some strange reason, the offer endpoint goes down. So I'm gonna just kill my pod and I no longer have access to that endpoint, but my bookstore application is still running. And you can see if I query the current office, it shows me nothing. But sometimes I need this kind of information on my application, so I can rely on just let things fail on the back end. So what I'm going to show you is the code, just the code. Here I have an API gateway implemented using Spring Boot. So basically an API gateway just forwards the requests to the offer endpoint. And what I want to show you is this piece of code. I'm using Fein, which is a library from Netflix, and Hystrix, which is the circuit breaker library from Netflix, to implement this code. I created this interface, get all offers interface, which queries the endpoint. This endpoint, offer Angular, on this AP, on this URL, okay? So basically, what does this code do is it tries to reach the backend endpoints, and if the backend fails or it timeouts, like the default timeout on Hystrix is 1 second, or if it takes more than 1 second to reply, I'm just not gonna wait. I'm gonna give as a default answer this implementation. Okay, so it tries to reach the endpoint. If it doesn't return or gives an error, I'm gonna return just a super discount of 15%. Okay, better than the default discount. I'm gonna super discount. So I'm gonna show you a version that uses the API gateway and is using Hystrix and Fein to do that. Okay, then if I access the offer, you see. Now it shows me the super discount of 15% because it opened the secret from Hystrix and it no longer fails. It gives you a response, okay? And on top of that, you have a lot of more things to consider. I have another session which talks about microservice architecture only, and we have a lot of different patterns and different tools that you can have. But some things that you have to keep in mind: circuit breaker is only the first pattern that you're going to have to code for design for failure. You need a lot of more things. You need centralized logging and distributed tracing, and you need a panel to monitor if your microservices are working. You need a lot of stuff. So you might need to learn technologies like Zipkin, like Turbine, like what else, Hocular, and some log aggregators. We have a lot of them in the market. So you're going to need to learn all of that. You see, microservice has a high toll for your architecture, but it's worth if you're having integration issues and you want to scale your code base. So back here. So some questions that we have in microservices: synchronous or asynchronous? Because many people believe that microservices just, oh, I'm going to create a REST endpoint here, I'm going to call it through HTTP and request response pattern. Yeah, maybe for many use cases that's the simplest and best alternative that you have, but maybe you might have seen some sessions today talking about that. Maybe you need an asynchronous model for microservices. It all depends on scale. Again, a synchronous model has its toll. It's more expensive to build asynchronous systems because we humans, at least we normal programmers, we are used to creating imperative code which is sequential. And in a synchronous world, we need to change the way that we think. And at first, at least, it has a toll. You're going to be less productive. But for some use cases, that's the best possible alternative. So we're talking about, am I using HTTP REST in a synchronous way, or am I going to use a message broker? That's the question. And when I say message broker, I'm not talking about ESBs, just the message broker to exchange your messages in a synchronous system. Next question is, what about reporting? Because microservices architecture implies that you will have a separate database, a separate data source for each microservice. So before, you have a relational database. Everything was inside a single schema. If I want to generate a report, I just do a join, and I have all the information. Now I don't have this possibility anymore because I have a database here, I have a MongoDB data store here, I have a Neo4j, I may have flat files in other microservices. How do I create queries or create reports? So there are many different answers for that. One of the possible answers that I wanted to show you is you might want to implement the SecureRS pattern, the command query responsibility segregation pattern. Again, short version is SecureRS is when you use a different model for updating your business model and to querying your business model. I'm going to show you an example of SecureRS and event sourcing, which is another pattern, which basically means I have a bank account. I've modeled a bank account. You just don't expose your bank account as a REST service, yeah? Because or else people are going to be able to update the bank account, and when they update the bank account, they update the amount inside the bank account too. So then you create a model which is called transaction, which has the account number, the add or subtract operation, and the amount. Then you just apply the transaction model to the account, okay? Now you have a model which is called transaction to update. And then when you want to query your bank account, you don't want to query just the amount that is inside. Maybe you want to query the credit score. Maybe you want to query all the transactions too. You want to query the address and everything else, the investment that the person has in the bank account. So you have a different model for updating and a different model for querying. And that's the very simplistic version of SecureIS and event sourcing. I hope you might get the point. But one of the alternatives that we have for aggregating the information from many different data sources is TEID. TEID, that's an open source project. As far as I know, is the only open source project for doing that. TEID is a data virtualization platform. You can run TEID, and under TEID you can have many different relational databases, different data sources. You can have flat files, a Spark stream, relational database, MySQL, Oracle, MongoDB, Neo4j, and then you can issue queries to TEID, and TEID can aggregate all the results and provide you some kind of reporting. Okay. One last consideration that I would like to say to you is that when you use SecureIS and a message broker and a bank account example, maybe you're going to think, oh, but then if you're using asynchronous messaging, then maybe in my system I'm going to have event consistency, okay? But and I can't handle event consistency. My domain model requires doesn't allow event consistency. Then you might think that all of the banks in the world, they work with event consistency, which is a hard use case, okay? Money. So what I say to many people is that you have to think, really, you can't handle event consistency, because if banks works with event consistency, maybe you can work with that too, because you're going to have different timing for the information that you're working, and you must be able to program into your code how you handle this event consistent problem. My final message is remember, monolith to microservices is a journey. We're just taking the very first steps. We have a lot of things going on. I just shown you the very first thing from monoliths to microservices, but at Red Hat, at least, I'm personally responsible for this strategy, for this story inside Red Hat, and we're going to create many more articles, videos, tutorials, webinars. We have a partnership with O'Reilly. We're publishing some books about migrating monoliths to microservices. And if you want to know more about this path, I invite you to join developers.redhat.com, which is the place we're going to publish all of this material migrating from monoliths to microservices. And would like also to announce that since April 1st, I know it's not a good date, okay? It might sound like it's a lie, but since April 1st, the Red Hat Developers Program just announced that now you have all of the Red Hat infrastructure tools, operating systems, and middleware stack available for free for developers at a zero-cost developer subscription. If you just enter the site, which is hard to read, but it's developers.redhat.com. redhat.com. Then you can have all of the Red Hat stack available, including Red Hat Enterprise Linux, available for you at no cost. So if you had troubles accessing some Red Hat projects or tools, now you can do that all for free, including the knowledge base, the articles, the materials, the videos, and the free books that we publish. And that's what I wanted to talk to you. And I don't know if you have some time for questions, but for now, thank you very much. Okay.
What will be the first piece of functionality that you will take off from a monolith and put in into a microservice?
Okay, that's a good question. That's I have on my list of questions that everybody asks. This is number one. How do I choose? Okay, you see, it's not a technology decision; it's a business decision. So you're going to change. You're going to have to see. Usually, it comes. I have to change a functionality, or I have to implement a new one. Then you need to weigh which one is going to deliver me more value. Okay, then you need to see the candidates for bounded contexts, which honestly is the hardest part, because we are very bad at creating bounded context correctly. So this is the next step. Then you have to measure how big is your bounded context, how long it's going to take for you to implement. But one rule of thumb that usually the guys from ThoughtWorks, they say to you is when you decide to split your piece into a microservice, one of the main things that you have to consider is, are you going to take more than 2 weeks to implement that? If that's true, maybe you chose a too big thing. You should be choosing something smaller. Because if that's your first microservices, you're going to have to create a pipeline, infrastructure, to implement the libraries. You have to care about design for failure, which you never did before. So that's some of considerations. But that's especially one of the books that we're trying to write about, because that's a complex scenario. Okay, I don't have a short answer for that, because that would require a lot of pages. Okay, but thank you for the question.
Cool. I think that's we'll probably have to end there as we're slightly over schedule. But again, thank you very much.
Thank you. Thank you.